All right. Hey, everybody. So my name is Scott. I'm going to be talking a little bit today about the Sketchup API in Ruby. So first of all, I was just curious to get a sense for who in the room has used Sketchup before. Raise your hand if you're a Sketchup user. Okay, so about half of you. And how many of you have used the Ruby API that's attached to Sketchup? Looks like nobody. Okay, cool. So I'll just go through this really quick. Sketchup is Google's 3D drawing tool. It's been around for quite a while, and it's used by professionals and hobbyists alike. It's really easy to learn, which is its claim to fame. And there's both free and pro versions available. On the technical side, it's a client application. It's not a web app. So you download it and install it to your machine like you would Adobe Photoshop or Google Earth. It's available on the PC and the Macintosh. And it's written in C++ and Objective-C and uses OpenGL for display. And what we're here to talk about today is that it has a Ruby language programming API underneath the covers. So a lot of people have this question of how do I get the API and what exactly does it do? So if you have SketchUp installed on your machine, then you have the API. There's no additional steps that you need to do. And to interact with it, you write a Ruby script, which is just a text file, and you put that script into a particular folder in the SketchUp installation folder. And then you restart SketchUp. And when SketchUp gets going, it basically consumes all the Ruby scripts that it finds in that directory, and it reacts to whatever you told it to do. And you do that via this object model that the API exposes that's really powerful, really consistent, and is obviously designed for 3D. So here's just a few examples of some code snippets that you might see in a typical Ruby script. So there's a SketchUp object that you can get access to the active model that the user is interacting with, grab the camera, and either figure out where that camera is located in space or manipulate it with the first command there. And the next one's an example of how you might get a handle to a given entity, a given 3D object that's attached to the model, and transform it around in space. You can rotate things, you can move them, you can scale them. All the sort of standard 3D transformations are exposed through the API. And the third one is a simple example of how you might apply a color to something. So what we're going to talk about today is kind of an overview of some advanced Ruby API scripting techniques that interact with the web. And these are done via a mechanism called Web Dialogs, which is a way that the Ruby API can pop open a little browser inside SketchUp. For the PC version of SketchUp, Internet Explorer is the browser that gets embedded. And on the Mac, it's WebKit Safari. And it's a full instance of the browser window. So you have a JavaScript environment in there. You can make AJAX calls. You can display user interface. So a lot of people, their first exposure to Web Dialogs is to have some sort of pop-up interface to add a plugin to SketchUp. But since it's a web window, you can then go talk to the web and do some interesting things that we'll talk about. The other thing that we'll talk briefly about today are Ruby extension modules. This is a mechanism that's really part of Ruby, not really part of SketchUp, but it's a way that Ruby can have a binary native code extension module that lets it do things, at native speeds. So physics simulations, complex rendering algorithms, all those kinds of things. You can write your own native code binary in whatever language you prefer. And there's just some kind of coding standards that allow Ruby to then consume whatever object that you've exposed and do some cool stuff with it. And in addition to better performance, this is also a way for you to have better IP protection of your code. So if you're interested in using SketchUp as a platform to build a commercial application on top of, there's a free version of SketchUp that's available to any user, and the Ruby API is fully featured in that free version. So if your company does garage design or something like that, and you want to provide a design application to your clients, SketchUp could be used with the Ruby API to do that. And whatever code you compile into an extension module, obviously no one will have access to your source code. Is there a question? The question was, does a Ruby script, can it be attached to a model? So you can email a 3D model to someone and have them use it? And the answer is, it is not attached. It's a separate thing. So you'd need to write a little installer that puts some Ruby scripts and your extension modules into the appropriate directories, and then they could interact with it. There's also, just to mention it, there is a scrambler that's available as part of the API package that you can get from the code site that will take your Ruby code and scramble it up so that it can't as easily be reverse engineered. But extension modules are an even more secure way to do that. So we're going to go through a series of techniques, and the first one is the ability to open up one of these web dialogues and grab some data from the web and render it. And how it works is that you open up a web dialog inside SketchUp, and then the JavaScript or whatever inside that web dialog goes and gets the data. And then with some JavaScript calls, you basically tell the Ruby API to do something. And so I'll show you a couple of examples of this. Here's a simple example of this is an embedded web window. So this is Internet Explorer running on the PC. And basically, I'm going out with an AJAX call, and I'm getting a CSV file back from Google Finance for General Motors in this case. And then I'm using Ruby to draw the last 30 days of stock prices and calculate a color for that chart. So this is just a really simple example of something that could be made much, much more powerful. The data sets that you can access can be as large and as complicated as you want them to be. You're not limited to just drawing simple boxes and things. You can draw anything that you can draw with SketchUp's physical, manual tools. You can draw with the Ruby API and more. So that's one example of going out and getting some data. Here's another one. This is Internet Explorer again, and this time we've got the Google Earth plugin, which is running in this web dialog. And so I can type in an address through their JavaScript API, and I'm going to zoom down to Denver, where I'm from. And so, and then using their JavaScript API, I wrote a simple line tool that I'm just going to trace out the footprint of a building that I might be interested in modeling in SketchUp. And then push a button, and what happened right there when I pushed that button was the JavaScript API was recording all the points that I was clicking in latitude and longitude, and then I sent that down to SketchUp, perfectly scaled and accurate. So then I could model off the top of this. So that's an example of a more powerful kind of UI that then sends data down to the Ruby API. And things can go back and forth as well. So a common use for the API is to have a script that does reporting against the contents of the model. So back to our garage design example, you could publish a catalog of your 3D content to your own website, have that website pop open in a web dialog, and then users could just drag and drop SketchUp files from your website into their model. And though you can't attach scripting to models, you can attach attributes to models and have those carry along. So you could record the product numbers, the prices, and those sorts of things to those objects. And then you could have like a shopping cart script that walks the model, generates a bill of materials, and sends that back up to your website with a buy now link. So that's a way that even though SketchUp isn't a web application in and of itself, you could integrate it with your web application. So another advanced technique, this is one that I haven't seen anybody out in the Ruby community do, but I think it has some really interesting applications. And that's that with a little trick, you can hide your web dialog. So rather than having it persist and float in front of what the user is doing, you can basically open up a web dialog, and then if you're on a PC, you just do a mydialog.setPosition, and you position your window at some ridiculous pixel location that's way off the screen. And so the web dialog is there. The user never sees it. There's no place that it's exposed in the SketchUp UI. And it provides you with a permanent JavaScript environment. So your Ruby script could need to get something from the web, and you could write a little bridge that allows JavaScript to go grab that for you. The JavaScript can take control at any time as well. So in addition to sort of giving Ruby access to the web, you could have another sort of process running, if you will, that could step into SketchUp at any time and do stuff based on what the user is doing. So it could be watching what they're doing, and maybe it automatically applies some attributes to the things that they're doing. On the Macintosh, it's even easier than on the PC. You don't have to do the trick where you position it, you just don't show it. So on the Macintosh version of SketchUp, the moment that you open a web dialog, the web dialog exists, and you can make API calls to it, send data back and forth. And just a quick example of that is you saw the stock thing that we did before. So even though you can't see it in this window, if I go to the draw random stock thing, I've got this hidden call that basically goes out and just pulls a random stock from that. And so I've got web access live from Ruby without having to hand code my own or ship one of the CGI libraries with Ruby. You could do it through the embedded browser. Okay, so another technique which can do some really fun things is to use web dialogs in Ruby to control the camera. So in addition to being able to create geometry and so on, as you've seen, you could take a handle of what the user's viewport is and you could move that around the model. One of the things that you can do with the Ruby API is at any given point you can save out a 2D snapshot of the user's current view. Sort of practical application of that is there's a recently released tool called the Web Exporter from Google. It's this little button right here. And what it does is it's using this trick of this is a web dialog that has a local HTML file that gets shipped with the plugin to present this UI. And you can make a few selections about what kind of movie, if you will, you want to export. I'll overwrite my last one. You can see what's happening here is that the API is rotating around the model in 10-degree increments and exporting a series of JPEGs to your hard drive. This is now a little preview window that you could post on your website and give the user the ability to spin around a 3D object. The perspective that you choose when you're doing this, so sort of the elevation and so on that you choose, is the thing that determines what gets exported. So you have a fair amount of control over this little widget that now will work on your website if you want to display a 3D product or something like that, without the end user having to have Flash or some 3D plugin or anything like that. It's just JPEGs and JavaScript. So this web exporter is available on our website, sketchup.google.com. If you go to the download sections and select plugins, you'll find the web exporter. And it's an open source project, so when you grab the thing, you get the full source code, and we're encouraging people to contribute. I've already talked to a lot of people at the conference who've had some really cool ideas about being able to select multiple points in your model and export multiple spins. There's been requests for folks who want to be able to stand inside a room and have the camera spin around in one space. You can have sort of a 360 experience. That's something that a competent web developer could add to this and contribute back to the project. So if there's something here that it's not quite doing what you want, please contribute. So everything that I've shown you so far has been more or less a static kind of experience. We're creating geometry and then viewing it. One really fun technique is to create a timer in JavaScript. So JavaScript has this method called setTimeout, where basically you can say, I want JavaScript to call this given piece of code, and I want it to do it on a regular basis. So this little snippet here is saying, call my function next frame and do it every 500 milliseconds or half a second. And by creating a web dialog, either a visible one or one of those hidden ones, you can create, using this method, an animation timeline that runs in the browser's thread, not in SketchUp's thread. So the browser's sitting there running this little timeline, and with each frame, or however you want to structure it, it can reach into SketchUp and tell Ruby to do stuff with the inside the drawing. So I've always wanted to do this, so I did. I got a model of Yoda from the 3D Warehouse, which is a free repository where people upload a lot of very strange models. And so I found this little Starfleet Yoda guy. And this Yoda dialog, if I click on unpause, this is an example of this web window is doing a timeout every 1/10 of a second or so. And it's then sending a transformation down to the Ruby API, which is making our Yoda spin around. And the cool thing is that I'm still live in SketchUp here. So while this little process is doing its job, I can be out here modeling things and so on. And you can start to imagine some pretty fun interactive experiences doing that sort of thing. Let's see. Another sort of related technique is you can always have a web dialog pop open, and you can capture keystrokes in that web dialog. In the SketchUp Ruby API, there's not sort of a base way for you to capture keyboard strokes unless the user has one of your tools selected. So in SketchUp in general, at any given time, the user has a tool selected, be it the line tool, the rectangle tool, and so on. And you can, with the Ruby API, create your own tool. So you could have a tool called nudge or something like that would allow you to, while that tool is active, capture keystrokes and do something with them. But with a web dialog, you can sort of capture keystrokes at any time, so long as that web dialog has focus. A related thing to this is that there are two ways to show a web dialog in SketchUp. You can just show it, which just has it, as a floating dialog, or you can show it modally with the show modal command that you see here. And if you do that, then the window, is a modal window, so it doesn't allow the user to interact down with SketchUp. So you've taken total control over the user experience at that point. So here I've got my moving Yoda example. And in this one now, you can see as I click around, I'm clicking on SketchUp, I'm trying to select different tools and so on. But my Yoda dialog is persistent and modal. So I'm basically saying, sorry, user, you can only interact with SketchUp the way I let you. And in this case, it happens to be that I'm capturing keystrokes. So you can see here, I'll zoom in a little bit closer. See charming little Yoda. I'm using the keyboard here to move Yoda about. So you can build some really advanced tools with this. And back to our example of the garage design company, you could say have a user interface where by selecting certain keystrokes off of a menu and so on, the user could place things in absolute positions following the rules of your product line, what have you. It's pretty flexible. So where this all kind of comes down to is that once you open up these web dialogs and you start giving all these hooks into UI and so on, you could go so far as to start creating full games in SketchUp that you could share with the community. So I went ahead and put together this example. And here, what we have is we have a SketchUp model. This was all drawn and rendered in SketchUp. And this little knight guy, this bar along the top is a web dialog. And that web dialog is capturing keyboard strokes. So I'm just using the arrow keys to make this little guy jump around and so on. He can jump around, he can swing his sword and get rid of these little soldier guys. And with this, I have access to all of SketchUp's sort of easy-to-use modeling tools, so that building a commercial quality game using professional tools, they can be very expensive and hard to learn. We think it's a pretty interesting possibility for kids, for example, to be able to use this technique and build some fun little games. So, this little guy jumping around. A little bit more about the technology that's going on here. This is basically a combination of the various tricks that we talked about. There's a setTimeout that's happening inside this web dialog, where every 1/12 of a second, it's capturing keystrokes. It's keeping all the game state in the dialog itself. So there's JavaScript arrays and stuff that are recording where the various objects are. And then with each frame, it makes a call down to the Ruby API and says, move my knight to such and such a keyframe, change his position and his rotation in space, have him leap to his demise. If I go ahead and turn off that web dialog, we can kind of explore this model a little bit and make modifications to it in a live fashion, have it pop back up, and so on. Here's another just a different map. So same code, same basic animation, just loaded in some different geometry. And since this is SketchUp, and I don't have this as a modal dialog, it's just a regular dialog, I can use my familiar SketchUp modeling tools to just come in here and modify the world that our little knight is jumping around in. Oops, he fell through. On the collision detection side, a few people have asked about this as I've shown the demo at the conference. SketchUp has a really simple method where you can do ray casting. So ray casting meaning I'm just creating a point at the base of his feet, and then I'm casting a ray downward, and it returns me an array of every object that ray passes, every entity in the SketchUp model that it passes through. And so as I create new faces for him to walk on, get my keystrokes here, that ray is going down through his feet, and it's finding that face, and it's determining, okay, that's my ground plane, so I'm not going to allow him to jump. But if I move that, it's immediately going to recast the ray. If I move it all the way down, well, or if I delete it, he falls to his death. So, I wanted to have Yoda in this one as well, so that the little knight guy could fight Yoda, but as we all want. But the problem is that that Yoda model is several megabytes. I downloaded it from some guy on the 3D warehouse who's now going to be famous, and it just wasn't practical. So I'm just casting a few rays here, and so if I move this thing down so that it's blocking where his feet are, he's not able to walk. I'm just capturing that, oh, there's an object to my right, therefore ignore those keystrokes. But if I swing my sword, I'm just taking that same ray that I grabbed and just deleting whatever object it is. Question? Yeah, well, so you could do it a number of different ways. You could certainly animate every joint. SketchUp doesn't have inverse kinematics or anything like that. SketchUp is not a character modeling tool. And so what I did instead was, if I turn on my hidden geometry here, you can see that this guy, well, maybe you can't see, it's kind of a mess, but he's actually made out of several different keyframes. So I can go to my outliner, which is just a tree view of all the objects in my drawing, and here's my hero component. And inside the hero, as I select each of these frames, you can see that there's just something that I hand drew. So I just sort of built the sprites, if you will, and just transformed them one at a time. But since SketchUp is an instancing modeler, so that you can have multiple instances of the same object, this head component, for example, is used in every one of those animation cells. So if I add some ridiculous plume to the top of his head, and then pop all the way back out of my tree and restart my game, then you can say that all of those frames have now absorbed that change that I made to the geometry. So now that I have one really good walk cycle, jump cycle, swing sword, and I think I can shoot in this too, yeah. So he's got a little crossbow on his arm. Now that I've got all those, I could post this model to the 3D warehouse. Kids could download it, and then just by clicking down into the tree the way I did, they could make changes to the geometry and turn this knight into, some other character, and all the walk cycle and stuff would be preserved. So that's kind of what's going on. Another thing that's fun about the game concept with SketchUp is that SketchUp, one of its strengths is it has all of these different rendering styles. So I could pop this over into a blueprint game. So it's still live 3D. It's still being rendered in real time. But now I've got this very interesting style. And there are dozens and dozens of these, and you can build your own with a tool called Style Builder that is available with SketchUp Pro. There's a lot of really great sketchy edge styles as well, so it can look hand-drawn. So that's pretty interesting. Okay. So the last thing I wanted to talk about a little bit is we were talking about mostly web dialogues up to this point. The other thing that I mentioned at the beginning are the Ruby extension modules. These are the things that allow you to have the binary code that's running underneath SketchUp. There's a plugin to SketchUp that's really famous now called Sketchy Physics, where one of our users took an open source physics engine, turned that into a Ruby extension, and then wrote a little Ruby shim that allows you to not only have physics embedded in SketchUp, but also to have UI to control and attach physics and so on. And so I was just going to play through this and let you guys see a few of the examples of what a Ruby extension module can do. So all of these animations that you're seeing here, these are just SketchUp models that somebody drew them in SketchUp. They used a user interface that was exposed through the Ruby API to attach weights and physics primitives to all these different shapes. And then you basically can hit the play button and kick the physics off running. So you can apply inertia and velocities and so on. And YouTube is filled with dozens and dozens and dozens of these little videos of these clever Rube Goldberg kinds of devices that people have built that are all just running a physics simulation in real time in SketchUp. SketchUp has a really nice, for lightweight geometry, a really nice rendering engine. It's got a very satisfying kind of feel to it. There's those different styles that we talked about. And because the modeling tools in SketchUp itself are so easy to use, this is something that is extraordinarily popular with a lot of teenagers and students and just people like me who have way too much time on their hands. I love this one, the little balls that are rolling around. So that's an overview of some sort of advanced techniques, and I'll just let this guy run through. While this is running, are there any questions, technical or otherwise? No, the SketchUp player currently does not have any API support. So you can use this the SketchUp player to embed SketchUp views in your own application, for example. But the Ruby API isn't implemented with that out of the box. Yeah, I've asked this question many times of the folks who've been at SketchUp from the beginning. The story that they tell is Joe Esch, who was one of the founders of SketchUp before we got acquired by Google, it was his decision. And one of our folks asked him one time, why did you choose Ruby? And his response was, well, it was either Ruby or Python. And that was all the information that anyone seems to know. So Ruby is the one is the one sort of customer-facing Ruby application that Google supports, and therefore it's kind of fun to be the one exception to the rule, since Python is our official language. Yeah. So if anyone wants to record this stuff here, here's a few spots that you can learn more about this stuff. You can get SketchUp itself at sketchup.google.com. The free version is available, as I said, for both Mac and PC. And you can also get the pro version of SketchUp as an 8-hour trial. And that trial is actually 8 hours of usage time. It's not 8 hours of just having SketchUp on. It's only when you're moving the mouse that we're sort of counting against your 8 hours. So it's more than enough for you to get familiar with the tools and run through the video demos and so on. The best way to get into the Ruby API is to learn SketchUp first. So on the sketchup.google.com here, there's also links to video tutorials that walk you through every single tool in the SketchUp user interface with a lot of examples. And it's the best way to learn SketchUp. That's how I learned SketchUp. And then from there, you can go out to the API documentation site where there's a few simple examples. And there's the SketchUp API blog as well. Go sign up for the API blog, and I'll be posting a blog post after the show with links to all of these demos. Once I clean up my terrible source code and add a few comments so people know what's going on, then you can get any of these things and play with them yourself. And there's also a pretty active Ruby user group on the Google Groups that has a few kind of hero users on it that are API experts and will reply to any request politely and quickly. That's another way that I learned the Ruby API, was by standing on the shoulders of all the really great guys on that group. So, okay. So if there's any other questions, I'd be happy to address them. It's a simple question of distribution. So you can obviously, Ruby has a lot of great libraries that allow you to make CGI calls and so on. But the actual kind of directory structure of a lot of these libraries is nested several folders deep, and there's dozens and dozens of files that go into a full distribution of one of these modules. Whereas the web browser just comes with every install of SketchUp. That being said, Ruby is a fully featured language, and there aren't any restrictions that are placed on the Ruby API by SketchUp itself. So we don't enforce a certain safe mode. So long as you can convince an end user that it's safe for them to install your script, you have full access to the operating system and full access to their internet and all that stuff. So, the Web Dialog thing isn't necessarily the best way to go for all applications. Sure. Got another question? You can get some resources on the internet for how to do Ruby extension modules. I'm not an expert in that. I haven't done that very much, but that's essentially how they get implemented. So like the work that I have done was like taking a Visual Studio project, like a C++ project, creating a form and attaching events to it and so on to create a user interface, and then compiling that to a DLL. And then from there, there's just a certain naming convention for how you have to, like the names of your methods that match to the name of your object, and then Ruby can pull it in. But if you go do a Google search on Ruby extension module, you'll find a lot of great tutorials that can walk you through that. So, okie dokie. So I'm going to be at the Sketchup API booth, which is down at the Geo thing. If anybody wants to actually see any of the source code, I'd be happy to walk you through it and show you how everything works. None of these examples are more than a couple hundred lines of code, so there's nothing here that you couldn't absorb pretty quickly. And I'll also obviously be right here if there's any additional questions. You can come on up. Okay, thanks.